Uh, Thanks everyone, and I'm hoping you can see CDC Unplugged and not my chat GPTs, because typically that's what usually happens when I share first chat GPT comes up. So I'm hoping that is not the case today. Anyway, so just a quick introduction about me, won't take time. I'm Varun, been data practitioner for over 13 years, working with Mathco for 3 years, heading the data and ML engineering unit. And my current focus is to make sure that we architect the best solution for our customers. I'll just leave it at that. So before we get into any of the details, right? So I just first want to set some groundwork on why are we talking about this topic? Is it like something that has come new in the market? Because every webinar we go with, every LinkedIn post we see, every news articles we read, it is all about AI. So now all of a sudden, why CDC? Now, to be very honest, this is not a new phenomenon. It is not a new technology. It's not a new word. It's been there from ages. Like when I started my career 13 years back, I remember distinctively. I remember one of the programs I was running with working with one of the investment banking customer, where we migrated their legacy system from Oracle to, in the target, they again had to do push Oracle. They were upgrading the version, and they were also moving the data on the modern platform. The application side changed a lot rather than the data side. Back then also we used CDC, right? So CDC, the full form, if you all are not familiar, it's change data capture. So it's nothing but capturing the changes on top of data, right? Now, where the misconception comes is, CDC people tend to relate this with real time and streaming all the time. I'll use real time and streaming interchangeably for today's conversation to make it a little simpler, but we know there are nuances in real time and streaming as well, right? So change data capture is not just restricted to real time integrations, right? It can be also applied to any batch systems also. But the essential part is any changes that happens in the data, you capture that and you transmit it to the downstream system so that the decision making can be enabled, right? When I talk to a lot of data engineers, when I myself was practicing actively data engineering, and then as when I was we speak with a lot of customers, one mistake that we tend to do is we see data from left and then go towards the right rather than going from right to the left, right? So what I mean by left to right and right to left is always look data from the consumption side, where what kind of insights you wanted to generate, how fast you want to generate that insight. So if you have a system where, let's say, there is a recommendation engine you have built, you have gone to Amazon website and you want to see real-time recommendations, that's where you need real-time data changes and data patterns to come in, right? Whereas, let's say if you want to look at your HR data, for example, very simplistic example, right? Where real-time insights is not that much of an essence. There could be few nuances, but in majority of the cases, where just a report needs to be generated or per day, events needs to be shown. In that case, there is no need for real time. In both the cases, the changes can to data can happen. You can still capture those changes. Now, when I say change, essentially in very simplistic term, it is either insert, update, or delete, right? So that's what change we are talking about, right? That's the transactional change that can happen. So what I'm trying to get towards is when you look the data from the consumption side, then you essentially know that how your entire system all the way from right to the left will move and how it will work, right? So if you need a real-time transaction, you need to build a low latency system. If you don't need a real-time transaction, you would not essentially do that, right? So that's where the nuances come in. And CDC is also not just restricted to real time. You can still capture changes at the source. You can propagate those changes as and when you want, right? So there are tools and systems which you can use, which we'll talk through also as we move along. So the example I wanted to start off with this is that, while on this slide you see some other example, but overall the idea here is that how can you make sure that your decision making is enabled, and CDC is a framework or a methodology to enable that decision making at the end of the day. There's nothing more than that, right? So it's capturing the changes in your data and propagating it, right? Now changes on the event can also happen like, you know uh, in multiple different ways, which we'll talk as we move along. Now, talking about this example, right? So what typically happens in a CDC is, let's consider a process where you have a PostgreSQL database or any other database for that matter. you have an internal in between a tool or a system or an orchestrator or a technology, and in the target you want to sync those changes, right? And let's say a target system is Snowflake. Then what you essentially do is any changes that happen, let's consider a table, a customer table. Customer table has a million record. Out of those million records, 20,000 records changed. The changes are 10,000 customers were deleted, 5,000 customers were updated, 10,000 customers were updated, and also let's say 5 more thousand customers were inserted. That is a change. So you detect those changes, the insert, updates, and deletes on the customer transaction, and then you propagate it down and push it to your target system. Now, your target system need not be a database, and your source system also need not be a database, right? But in traditional sense, when we talk about CDC, it is always database to database in traditional sense, but things have evolved as we know, right? So any changes that happens at the source side, you identify those changes, you perform some operations on those changes, and then you basically push it to the target system. Now, the use case that I was talking about, right, the program that I work for a long duration of time. So at that time, customer were moving towards. So the customer was a European customer where they were implementing a lot of regulatory mechanisms back then, right? So it was like I think 9-10 years back. So what we used to do was, since they were migrating from legacy to new system, what they wanted to do was they still wanted that any changes that happens on the source side continues to get trickled down in the target side till we have migrated the entire source to target, right? Because there is a migration phase. It was a 4-year program. So first 2 years we had to keep the old system alive, and while moving to the new system. So to keep the old system alive and maintain the new system, the best way was to make sure any changes that happens in older system, just take that and propagate down to the new system as well, right? So that's where we were using change data capture back then. So we were able to process one single transaction in around 2 to 3 seconds back then, which is a great achievement back then, right? So we were using a tool called Informatica Power Exchange. I'm sure some of you new data practitioners wouldn't have even heard about that tool, but you would have heard about Data Informatica Power Center, let's say. So we were capturing the changes using Informatica Power Exchange, using Power Center for transformation, and pushing it to the target. The reason I've mentioned these tools are to capture any changes, you need help of a tool or a custom code, right? For simplicity, I'll just keep it as a tool level right now. Power Exchange was a tool which allowed which captured the changes from the source data side, right? So here in this case, let's say we are talking about PostgreSQL. Sorry, excuse me. Yeah. So any changes that happens here, the tool will, this particular change data capture process, consider this as a tool which will capture that changes and propagate down to the target. So this is essentially change data capture. So what we have learned so far, or understood so far, or discussed so far rather, is change data capture is nothing but allowing to capture any transaction that happens on a source system, potentially a database, and propagating it down to the target so that decision making can be enabled, right? So I've talked about, so today what we will go through is what, why, and how of CDC, which I think I've been talking about from last couple of minutes. Explore popular tools and technologies, which is very critical. Understand its relevance in the modern system. Now, modern system, by that I mean is there are a lot of new platforms that have come in, right? In analytics, a lot of us use Databricks, Snowflake, Fabric, all of the likes, right? So how can we take those systems and can we implement CDC on top of it, or is there any mechanism to use CDC on top of it? And then finally, we'll have some real world insights into how CDC goes. So, like I mentioned already, CDC is nothing but insert, update, and deletes on a database that you capture. It keeps the system synchronized with real-time updates, right? Now, don't take real-time updates as a literal meaning of CDC. You can also make sure that you can capture these events. Let's say there are 3 events: insert, updates, and deletes. You capture these individual events, you batch them up, and then you basically, after 2 hours, let's say, you can update the target system, right? That's also, nothing changes. So CDC is just a mechanism to capture the change. Everything else is dependent on what your target consumption wants, right? Like I talked about, go from right to left. Don't just think about left to right, right? Now, commonly used a lot in data integration, because any changes that happens at the source, you just want to integrate it and make sure that you publish the changes. Replication, like I said, Database to database replication is a huge application of CDC, right? Where any changes that happens in one database, you want to propagate to the target. Because what we have to understand is, in any organization, there is a transactional system, or which we call it OLTP systems, and there are analytical systems, which we used to call it OLAP systems, and now lakehouse or whatnot, right? So to keep these two also in sync, if we remove all the other complexities of the world, to keep these two systems also in sync, there is a need to basically integrate data or replicate data, right? That's where integration, replication, warehousing all comes together. Now the key benefit, of course, is that it allows you to maintain the data consistency and enables timely updates across different applications, right? Now excuse me. So I already talked about low latency not being the only part that you should focus on in CDC. I'll not repeat. But CDC allows you to have efficiency and resource optimization. It allows you to have incremental data movement. It minimizes the downtime, and there is an adaptability to fast changing data landscapes. I'll not spend too much time here. The common architecture pattern: you have a source database, the changes are detected, you have CDC tools of choice, there are multiple tools, and then, like I said, you can push it to any system you want. You can put it into a data lake, a data warehouse, an index, right? A search index, for example. Let's take an example of you have a Elasticsearch, right? If you're not familiar with Elasticsearch, basically it allows you to basically search through, it keeps index of data, and then it allows you to search through those indices, right? So any changes that happen on the data, let's say if there are only minute level, like one or two transaction or one or two rows are getting updated, the entire index need not be changed, right? So you need to refresh those specific pointers and propagate it down to the target system. That is also possible using change data capture, right? So your source and target is independent of this mechanism. This mechanism can work on any source and target as long as you keep the fundamentals right of allowing the source and the target to understand what an insert, update, or a delete transaction means. That's the fundamental thinking on CDC, nothing beyond that. You can write a SQL query to implement your own CDC. You can write a Python code to implement your own CDC, or any other language of choice, right? The tools are there to make your life easier, because when we come to enterprise grade scale, the complexity of the system increases, and hence tools allow you to march through those complexities. Now, this is critical, right? What you have to understand is, in CDC we talked about, yeah, CDC is insert, update, delete, but what really happens in the source side that allows you to capture those events, right? So in traditional CDC methods, I'm talking about like back in the day, 10 years, 15 years back, right? There were trigger-based CDCs. For those who doesn't know what trigger is, trigger on a database is nothing but any changes that happens on a table at a row level or at a column level. You can basically log a change, and you can say that, hey, trigger an event, and then that event can do action. That action, what in trigger-based CDC we used to do is, we used to write it into a separate table, right? So that trigger based CDC would write it into a separate table, and that would allow you to then take action on top of that table to say that whether it's an insert, update, or delete, and then you can basically propagate down to your target system. Clearly, you can understand that when you apply a trigger or any event on a database, you're putting a lot of load on the server, you're putting a lot of load on those tables, because there is reads happening, there are writes happening on those tables. And hence this had a lot of performance overhead in general. Then you can have your custom way of thinking of CDC, like you can have a timestamp, you can have a flag, right? Where you can say that a query that has a last modified timestamp greater than, let's say, 31st December 2024, I want to capture all those events. That becomes your timestamp based CDC, right? Again, limitation is you need to have timestamp or search columns integrated, and there are often chances of high frequency updates to get missed, right? And they may not be a sequential way of looking at these transactions, because at the end of the day, when you're querying greater than something, you may not get those sequential records, right? That's where log based CDC, when I say modern, it has been there for like 10 plus years. It's not like something that has come up of recently, right? But this is widely used in majority of the database systems that you do. So if I take an example of, let's say, Oracle or PostgreSQL, they use something called write ahead logs. So what it does is, Any transaction that happens, they generate a log or an event called, it's an insert, update, or a delete, right? So basically that gets logged into literally a log file that gets stored on a server of that database, and then from there you pick basically what kind of events have been generated. So by doing that physical separation from table to log, you are essentially not putting a lot of load on your system. So that's where log-based CDC took a lot of traction. In different tools, databases it calls differently. Like in MySQL, it's called binary logs. Postgres and Oracle, it's called write-ahead logs. SQL Server Exchange tables, right? So these systems allow you to basically capture those transactions, these logs, those events you capture, and then you basically process on top of it. Now, these events are captured by a lot of connectors that are built, and connectors are part of a lot of databases, a lot of systems, a lot of tools that you use, right? Now, the biggest advantage of log-based CDC, as you can know, is low impact on the source database, because essentially you are reading out of logs. You're not consuming the capacity of the database itself, right? Now, there are event driven and streaming CDC also that you can think about, but essentially what it means is it just integrates with your distributed systems so that you can enable those faster decision making, right? But your fundamental of capturing the data at the source level, the change of the event still remains the same. Whether you are using a database, whether you're using a data lake, any open source table format like an iceberg, hoodie, or delta lake, the fundamental of capturing an event remains the same. One more thing is that is critical to understand is, now CDC can happen at a row level, at a table level, as well as at a column level. You can change or identify changes at each of these levels, right? And majority of the tools support these levels. There's nothing that is different, right? So, like I said, log-based CDC, there is a database log that gets created from a source system. Let's say this database log says that there was an insert operation that happened on 2nd November 2022. There is a connector from a tool called Debazium. We will talk about it. This connector tool takes this transaction log, and basically it just, as soon as the changes happen, it just pushes it down to the streams, and it says that, hey, these are the changes that are happening, and your target system can basically take these system changes. One thing that is critical is, if your event stream does not line up your data in the sequential order of execution of when this happened, there are obvious chances of you will miss a transaction, or you will get the transaction wrong. So the complexity of CDC is in the implementation of this piece, where you are essentially transforming the data lining up the data and making sure that those events are happening. So to take a practical example from the use case I was talking about, we ran into multiple problems of where there's a failure in the tool itself, and at times the messages used to get dropped, or it never used to happen in sequential manner. So some of these tools, what they do is they also allow you to assign a token. That token gets saved intermittently during your event, and that when it gets saved, when the failure happens, you can basically, what you can do is you can take that token, reprocess that token, and you can get those files events from the time of failure. So all of those nuances is what you need to understand, or you need to take care of when you're implementing CTC method, and not focus a lot on the source side, because source is very easy to capture because of the tool based systems, right? Like I've been saying, CDCs primarily have been for databases, but it is not just for database, right? You can also have for non-databases systems, right? So let's say an object storage. So there is a file that has changed, right, in an S3 bucket or an Azure blob or GCP cloud storage. Those file changes can also be captured, and you can call it technically as CDC, but because it's nothing but a change data that is getting changed and you're capturing it. But you can look at related that way as well. But we don't look CDC from a standpoint of file system APIs, message queues, object storage level, but you can use it interchangeably if at all. I just wanted to bring in this nuance because there has been confusion in the past when I've been speaking to a lot of people. Now, what are the popular CDC tools, right? I want to focus right now on couple of three tools. In fact, you can still see my screen, right? Harsha, can you confirm? You're on mute if you're talking. Hmm. Hello.
Yes, Varun, we can see your screen.
All right. Perfect. So the three tools I want to talk today about is Debezium, Oracle Golden Gate, and Click Replicate. Right now, why did I choose these three tools? Because in my experience working with a lot of customers, I've seen that these have been there has been a lot of adoption in these tools, where Debezium is nothing but an open source tool which is built on top of Kafka. So when I say it is built on top of Kafka, basically fundamentally it is tied to Kafka, right? So you can't do anything beyond Kafka. Then there is a tool that you see here, Airbyte, right? Airbyte is a popular data integration tool that is open source that also uses Debezium for its CDC or change data capture mechanism, right? So Debezium, what it does is, again, it's a log-based tool, like we have been talking about, uses Kafka. It gives you the distributed nature because of the Kafka. You can basically push the stream down to the target and you can enable those streams. Uh, the challenge with this is, of course, you need Kafka knowledge, but the advantage, it's open source. There is community, there is organization adoption, and then you can go with it. Second tool is Oracle Golden Gate, which is again a log based, but it is more Oracle ecosystem heavy, but it does allow you to have Oracle to non oracles as well. It's a high performance enterprise grade system, and it has proven a lot in a lot of big organizations as well, right? Click Replicate is another, which is very again log based, but they call themselves as agentless because they don't put any agent on the database itself. It's a lightweight system, user friendly, very easy to adapt, and you can basically simplify your real time transactions with it as well, right? In the central pillar, you see ADF and Azure AWS DMS service, which is DMS is mostly used for replication of the data from source database to the target database. Azure Data Factory has a limited capability of CDC, but it does allow CDC for some of the systems. I think even for SAP, it allows you to use some level of CDC. But again, you can go into the documentation and look into more details there. Now, I've been talking about CDC from the standpoint of traditional systems. CDC can be on top of NoSQL databases also, like MongoDB. There's a MongoDB Atlas that allows you to capture extractions from the document database. It can be from ERP or CRM systems. You can basically build those systems also, and it can be based on top of file systems also, right? So there are tools and techniques that you can use to enable CDC on these systems as well. It need not be just one or two systems only. Now, given a lot of focus of my working area is on analytics, right? So one tool, a couple of tools that we generally get into is Databricks and Snowflake. So I thought of introducing or bringing up to all of your notice that on Databricks as well as on Snowflake, change data capture can be enabled. Now, what do I mean by that? Look, Databricks and Snowflake are a platform. At the end of the day, your change data capture will be eventually happen on the data itself, right? So when I say Databricks, you can understand literally that I'm talking about Delta Lake, right? Or Delta tables. So for those who don't know yet what Delta tables are, Table is built on top of Delta Lake file systems, which is an open source file system, uh, which is like similar to Apache Iceberg or Hudi. So here, what I've done is I've shifted my attention from OLTP system, and when I talk about Databricks, Snowflake, these are more of your OLAP or warehouse or lakehouse systems or data lake systems, right? But the nuances of capturing the changes are still the same. Like Delta Lake, for example, or Delta Table, for example, it maintains transaction log, as we all know, right? So if you have not read, please go and read it. It is very critical. The JSON file that gets generated, that captures events like update, insert, delete, what has happened. That same thing you can capture, and basically you can propagate it down to your target, and you can keep on building those systems on top of Databricks. It's called change data feed, or CDF. So consider an e-commerce platform which tracks customer orders, right? The table is frequently updated as new orders are placed, as usually happens. Now existing orders can be modified or cancelled also, right? It's not like all the orders will go through. So those modified or cancelled orders, if you want to capture those events, you can capture using change data feed or any other CDC mechanism. We are talking about change data feed here, right? Now, how do you enable CDC? Simple. You just need to alter the table and set a property there. The nuances you can check online, also very easy to find. But the critical part is, how do you understand the changes happen? Basically, it allows you to have a table changes function, which allows you to have start version and end version, and it gives you details of, hey, this is the change type, insert has happened on this, this is a new insert that has happened for order ID 101, a new update has happened for a 102, and 103 has been deleted. So then you can take these individual events and say that I want to delete in my target 103. It can be a soft delete or a hard delete. So then you can take events or actions on top of it, right? Similarly, you can also implement CDC on top of Delta Live table. Again, Delta Live table, though, for those who you don't know, please go and read about it. But it is essentially nothing but you can build. Basically, it allows you to have write DBT sort of scripts that, I mean, you can basically define certain decorators to say that what actions you need to perform on it on a table, right? So instead of, it's a declarative way of basically writing your tables, right? So any changes that happens on your source system that you define, let's say to create a table, your table is created from a S3 bucket, a file in an S3. So you define on an S3, there is a table that is getting created. So Databricks, what, or Delta Live Table, what will do in turn is basically it will create an autoloader function, which will allow you to capture those events. So that's Delta Live Table. Apply changes is a function on API on top of Delta Live Table that allows you to do change data capture. You can read in detail, but I just want to throw in out there just so that, because there are a lot of articles out there you can read and understand details about it. On Snowflake, again, okay, one more thing I want to point out is, before I go to Snowflake, is on Databricks, etc. There is time travel that has come in. People relate that to CDC, etc. But those are not in real sense CDC, because those are essentially you're capturing bunch of events that you want to replay it. CDC at a very granular level is always talking about a unit change in general. How you process that unit change depends on real time or batch, which we have been talking about in length. Now, coming to Snowflake, right? On Snowflake, streams and tasks are the two-way you enable CDC. Stream is basically you say that, hey, I want to understand what kind of changes that are happening on the table. And task is basically it allows you to capture those changes, and you can schedule and see that at what interval you want to check those tasks, and basically then you can enable your change events on top of it, right? There are a lot of bunch of articles, medium articles. I've put some references also for your all of your convenience. You can go and check. But essentially, streams and tasks are two primary objects, database objects that allows you to enable CDC on Snowflake. Snowpipe is another, but Snowpipe is not a change data capture. It's more real time mechanism, so you can have those nuances cleared out, right? I think I already spoke about open source table formats and how Delta, Iceberg, and Hoodie takes care of it, right? I'll just talk about quickly about Iceberg, right? So in Iceberg, there are metadata files that are getting created, manifest files, essentially track those changes. Again, those changes are at a transaction level of what events that have happened. And Iceberg tables allows you to have snapshots, which you can capture using snapshot functions. And then basically you can time travel and look into those snapshot functions, right? Uh, so what we are essentially looking at is these open table formats. You can enable CDC on top of it by their inherent nature of capturing those transactions in their log, and then you can make use of those functions that they have exposed to you, and you can build your systems on top of it. Now, CDC, we have been talking about database all the way. I want to bring in certain nuances of how other applications have happened, right? So you can read this on your own time, but I want to point out 2 to 3 use cases. One that we have seen, like working with a lot of analytics customers, what we have seen is uh, whenever there is a need, whenever in an AI ML systems, right, there is a lot of, once you have deployed a model into production, right? So there are a lot of changes that happens on model as well as on the data. So when a change happens on the data, an event or an action needs to be taken on the model, right? Specifically, if you're dealing with a model which is very sensitive to data changes. So you can enable change data capture on top of those data. So we typically call in an AIML world data drift. And then based on that, you can take some event or action to, propagate it down to your target system, right? So that's how you can enable on an AML system also. Another example you can think about is Redis, Memcache. There are caching softwares that are right. So what they do is they cache. Let's take an example that you have run a SQL query on database and you have cached certain results on on these Redis or Memcache. There are certain changes that can happen on your data, and those are not very frequent changes. They happen like over a period of time, or in not in not very quickly. So those changes also you can capture, and then you can rebuild those cache rather than changing the entire cache, going to the database, querying the data again, storing it in a cache. You can just use a part of that cache, and then you can enable caching on top of it, right? That's another way of thinking about CDC. So application is not just in the analytics world, it is also in the application and how CDC is done, right? So CDC is a mechanism at the end of the day, right? That's the point I wanted to make more than anything else, right? Now, high level implementation strategy, I think we have been talking about choose a database that you want to track changes on, or any other source system. Choose between log, trigger, timestamp, or any other custom methods that you want to build. Use any tool of choice, Devasium, DMS, or your own custom code you can build. Connect CDC to a streaming platform if you really want to, organize those events and push it down to the target in real time. Push the changes to data warehouse or lakehouse wherever you want to change, and then basically you can track performance and optimize the latency, right? So it's a simple way you can do it at your, in your laptop, and you can enable any of these. The key advantage CDC, like I've been saying, is giving is it allows you to capture those transactions and take decisions effectively, right? But not everything is rosy, as we all know, right? In this world, and CDC comes with its own implications. So you cannot use CDC for every single use case that you want, right? So that's the biggest takeaway that you have to understand, right? Like, if your data is not changing a lot, right, then there is no point enabling a system called as CDC, because any new system you bring in has a cost implication, right? Or if there are systems that are have high throughput of changes with really low value to insight, right? Like logs, right? You cannot enable CDC on top of it, right? Because there is a huge throughput coming in, changes are happening. You don't want to enable CDC, right? Or if the database itself, completely your data is getting changed, right? Your entire table gets changed or refreshed every day. There's no point applying CDC, because capturing those unit transaction then does not make any sense at all, right? That's where you adopt your traditional method of pulling all the data in, and then use them, taking decisions on top of it. Like I said, there is infrastructure cost, there is licensing cost because you tie to a tool. There are operational overheads because you have to log, you have to monitor, you have to do a bunch of stuff, you have to hire a bunch of data engineers to even do that. And there is a vendor logins, vendor lock-ins, that risks that are there, and etc., etc. So there are a lot of cost implications also, right, attached to CDC. So I think I've been on a monologue for 30 minutes, but I think there's a lot to cover in the first half. And I just want to leave you with few things which I've been talking in general, right? Uh, it is used for tracking changes. It is different from real time or CDC because CDC focuses on data changes in the source system, while streaming allows you to propagate those changes into the target systems, right? CDC finds relevance in a lot of modern systems that I've been talking about and ensures data consistency across the systems, right? Now, some of the other use cases that you can think about is for real-time analytics on CDC, right? Let's say a retail company uses CDC to feed changes in their customer transactions to do their analytics in real time, right? This enables them to monitor sales performance, stock levels, and customer behavior without waiting for the batch updates to come in, right? So that's another impact, right? And the critical impact of that is like businesses can start making those data-driven decisions faster and identify those trending products or optimize their inventory, etc. Application of CDCs on those systems happens a lot on the fraud detection use cases as well, where financial services use it for a lot of use cases as well, right? I think these are some of the references. I just wanted to flash it where I took some inspiration from. I was going through a lot of articles And I think what I've seen over the last few years, not a lot has changed in CDC world, at least in the capture side. What definitely has changed is the overall time to insights that CDC can drive, or the events capturing can drive, has changed, because you have a lot of real-time streaming systems that are coming in out there in the market, right? So that's where I think a lot of these change systems have changed. But apart from that, I've not seen a lot that has changed over the last few years, right? Yeah. So I think with that, I think that's all I had in terms of laying the foundation of CDC, what it does, and how it works with Databricks, Snowflake, and all of those tools alike. So I'll hand it over to Harsha to take it from here, and if there are any questions, we can go through that as well. I can't see the chat, but yeah.
Absolutely. You can actually see the questions. So we can also
How can
start the live
I
answer.
unshare? I'm
But
just trying to
we have
see.
also,
Sorry, I'm just trying to see how I can unshare. Okay,
yeah.
new to this
Yes.
platform, by the way, so I don't know.
Absolutely, no problem. So we do have some of the questions which we can choose to live answer, and we have also collated a list of the question, right?
Right.
Yeah, which Shubham is going to ask. So guys, welcome Shubham. Shubham is our CTO. Hi Shubham, how are you?
Hey, hi. Sorry, am I on the mute or am I audible?
No, no,
You're
you're completely audible.
Awesome, awesome. Guys, I'm one of the co-founders and CTO here at DataZip. I have been in the data engineering space for almost last 9.5 years. Worked with a couple of good companies to set up their data pipelines and also handled, a couple of terabytes or 2 petabyte worth of a scale. So that's a quick introduction about myself, but I think really great presentation, Varun. You have almost answered most of the smaller doubts that people have who are beginning to start with CDC or halfway there. What we can do is I'll quickly take over. Sorry, Harsha, I cut you off, but I'll take the questions on the questions section, and then we can go over one by one, right? So, like, first question came from Mukesh. Like, could you differentiate between a log-based and Kafka?
Yeah. So look, Kafka, if you see, right, I mean, those are like event generating system. Log-based systems are within a database. When any event happen or transaction happen, that gets logged as an event. Where Kafka can take events from any source system, you can push it down. Kafka is a messaging, is it's a queue mechanism, right? Basically, it is used for only capturing events, whereas log based is an approach within a database that allows you to have those events from the database itself, right? There is no real comparison between the two. Like, even if you are trying to build CDC with Kafka, when we say Kafka itself is not capturing any events, it has a connector within Kafka Connect. Also, you can use the Bayesian Connect you via Kafka connector, and you can take those events from a log based system, and you can push it down to Kafka and to the Kafka topic, right? So Kafka itself is not capturing. I mean, there's a Kafka Connect that is capturing third party connector, and that third party connector connects to these log based systems. These log based systems are nothing but, let's say, your any database events that happens, right? It says event insert, update, delete. Literally in the log you will see a single record saying that there is an insert for this column, there is a delete for, or there is an update for this column when that happens. And the way it captures is when you fire a DML operations, insert, update, delete. That's how it knows that there is a transaction, this kind of a action has happened. So there is no real comparison, but I just want to still call it out that this is what it is. Yeah.
Great. Thanks for the clarity. So basically, one question came from Bharatish. Can we consider SCD2 similar or same as CDC? Basically, slowly changing dimensions, same as CDC.
Yeah. So look, you can think about, so when you talk about SCD type 2 in this case, basically what you're talking about is you will have saying that, hey, there is a change that has, I'm capturing that change. Change CDC is on top of that change capture, right? Again, SCD type 2 is a mechanism where it says that this is a change that has happened on a table that notifies you. How to act on that change is what CDC takes it forward. So remember, I was talking about timestamp based approach. So you can consider, you can build a timestamp based approach or any approach or a flag based approach on top of your SCD type 2 and say that it's a CDC for me, because there is a change that has happened and I'm capturing that change on that particular column or on that row to enable an event at the downstream, right? It does not necessarily mean that you can replace either or. But SCD type 2, you typically look at the consumption side again when you push down, but CDC happens at the source side. But again, you can, weird world, right? You can always interchange and think about things.
Right. So the next question came from Lakshman. So if data changes one time a day, will timestamp based CDC work, where we store the timestamp into one column?
So if the data changes one time a day, if you are putting a timestamp to the millisecond level, I'm assuming, then I mean, yeah, of course, it will work, because you are essentially saying that greater than a particular date or a timestamp. You can break down that timestamp into an hour, minute, second also, saying that, hey, I want to capture from 1th second to 60th second, store it in a file saying that I did it for a 60th second, and then take it from literally from 61st to the other. So it does not matter within a day whether you can always do it. I mean, it just depends on how you program it. There's no limitation there.
I
There's no
think
charges there either.
one of the problems with that, Varun, might be that you might not be able to track the deletes, especially if it comes down to if they want to track the deletes. So
Yeah,
CDC can help in that manner, and also like you'll have to maintain that timestamp column.
yeah,
Really.
correct,
That is for sure. If you don't have a cursor based scenario, then it could be a big issue.
correct. Agree.
Yeah. I think one of the questions from Priyansh is you mentioned about monitoring in the slides. Which specific monitoring tools or metrics one should track for CDC?
So I don't remember mentioning that. Maybe I have. But when you say word monitoring, which CDC, which specific monitoring tool or matrix you should track for CDC? So if you're talking about the source side, then those tools already take care of it, or an approach already takes care of it, log based, timestamp, whatever, etc. If you're talking about target, then it's the same tools that you can use. I don't really quite get that question clearly, but from what I quickly gather is your monitoring is more at a source level, then it's a CDC approach that you choose. If it's target, it's just enabling your normal ETL pipeline updates. There's no specific monitoring that you do with CDC per se, because it's just a mechanism to capture data or capture event rather.
Right.
Shubham, do you have anything? Because I might not have understood this really well.
I think, specifically to track CDC, there are not many tools out there, like in terms of how many records that you are pushing, or whatever. Like for Debezium, there could be some metrics that you can track, but there are no just a tools for tracking just a CDC.
Okay. So if the question is around how many changes that have happened, then you can do it with, let's say, even when you're pushing it down to a Kafka topic or extracting from Kafka topic, you can write into a table or a file, or within Kafka also you can store it down those events and aggregate and see how many records have inserted, updated, deleted. But like you said, there is no specific tool to capture this itself. Yeah.
Right. So next question come from Swati. How does CDC deal with the conflict resolution when multiple updates occur on the same data?
So again, whenever an update happens at the source side, the conflict at the source side, the database will decide which happened first, and it will keep logging those events. And those sequence of events is what the connector will pull and process it. The challenge that happens is when you're processing that data and there is a failure in between, that's where the challenge happens, right? Then when there are chances that you might miss an event, or you might have reprocessed two events, that's where you have to be careful in terms of which event you have picked versus not, right? So like, initially, like the tools that I was used to work with was always one time read of transactions, right? It will not have multiple. Like Debezium, for example, is at least one, right? So it can allow you to process multiple times. So the challenge with that will be you have to be careful how you take those events. But in general, you don't have to manage updates that have happened at the source side if you're talking at a traditional database level, because those are already neatly logged for you in sequential manner of how those events have happened. That's why
Right.
it has been very useful also. And I think it's a very good point, Swati, because that's where log based approach has also become very easy to manage. Because if you were using with timestamp approach, and if till the millisecond level it is the same, there are three events, it's very difficult to capture which came in first. So very good question, by the way.
Right. I think majorly the whole point of log based is database writes to the log first, and then it actually updates the data. Right. I mean, for example, Postgres maintains a write ahead log,
Yeah.
so it first appends there, and then so
Yes.
ideally database itself gives you that differentiation on which record is first and then what is the
Correct.
second. Awesome. So next question from two questions from Aditya. One is CDC operation in fact is on a fact slash transaction data, but SCD is on dimension. Can we consider this difference between SCD and CDC?
In a way, yes, because any transactional system is where you do CDC. But like I've been saying, even on the data lake, Delta Lake, you can do CDC. So just to draw simplicity, you can consider it. But if you realistically look at, CDC can be literally done at a before your data goes into a Tableau dashboard. Even on top of that, you can build a CDC, right? Because you're capturing a change event. That's it.
What are the challenges in auditing and versioning of CDC data?
When you say auditing and versioning, let me rethink about this. So, okay. So if you're thinking about the changes that have happened, then I mean, it's just literally putting a record in a table. It's as simple as that. There's nothing that you have to explicitly call out that these have to be audited or maintained for a longer duration, right? This will come as a similar transaction, right? So let's say you update a name for a customer. Your record will look like an updated name, right? Let's say from Aditya Shaw to Aditya XYZ. So your XYZ and Shaw will only change, right? So nothing else will change. So, and there will be a flag that will be inserted on top of it. You don't have to audit per se anything. Your transaction itself will be the fact of truth, saying that this is what the event is. That's the truth. You don't have to audit or version anything beyond that.
So I think Aditya, CDC is just a mechanism of the pulling that records or changes that just Varun mentioned. Now it's up to you on the basis of how you want to dump it or where you want to dump it. You can dump it in as simple as a, let's say, a data lake or a data warehouse which has that auditing and versioning capability. CDC is just a sort of a river that where the changes flow through, and the destination is something. If you have an auditing requirement, you can choose accordingly. For example, the Delta Lake and Iceberg, they have the time travel and sort of things where you can actually see what has changed.
Yeah,
Yeah,
good point.
I think most of the questions are done in this. So yeah, I think for the couple of questions that I wanted to ask for, like a good kind of CDC related things. Just a second.
Yeah.
I've made a list of some good questions. So, like right now, the industry is actually moving towards like AI and ML thing. So, where do you see that some patterns are emerging for CDC to be useful in the AI ML data pipelines? What do you think about that?
Yeah, I think one example I already mentioned during the data drift that happens, right? And you want to basically trigger because in the overall evolving landscape of ML ops, right, or AI ops for that matter. Let's take ML ops only for that matter. The idea is to automate your end-to-end system, and you want, when there is a drift that is happening, then there has to be if there is an event that needs to have model retraining that needs to happen, that's where you can enable a CDC on top of, right? That's one way of looking at it. Another thing that I'm talking more from practical senses, there can be like out there hundreds of use cases, but in all practical purposes, what we have seen. Another is there's a lot of feature store that you create, right? So basically, feature store, for those who don't know, for any ML systems, you build a lot of features. Features are nothing but attributes that on top of which models are enabled, right? To keep those features, up to date. When I say up to date, let's say you have created a feature to aggregate a particular metric, because you have defined a metric. To keep that up to date, because the data is ever evolving and changing. Let's say for a customer itself, right? You do a transaction, there is an order that you keep, putting on Amazon. So there is an average order value. That's a KPI that you're tracking. So that's a feature that says, that pushes, allows you to uh, work on your model. So this average order value is something you need to frequently update. So you can think of change data capture on top of it as well, right? But again, you can one more side of your brain can think about, hey, this is again similar to real time, right? What is the difference there? So again, the nuance here is only simple, that you're capturing an event, you're capturing a change, a delta change, a unit change rather. CDC, in my practical purpose, we have used or thought about only as a unit change and nothing more than that. A unit change that leads to a impact on decision is what a CDC is, and use CDC only then. Otherwise, it's all about real time, batch, whatever you want to call it. Yeah.
Right. I think that's a great couple of examples. So I'll quickly move to the next questions because we have limited time.
Yeah.
I think so. Like basically, what are the what kind of strategies that you usually implement in CDC to deal with the semi-structured kind of change data capture, where your change data is coming from primarily sources like MongoDB, because there could be a lot of schema changes and other things.
Yeah. Yeah, that's tricky, because I think, look, first of all, there is not a lot of in lot of organizations or enterprises, we have seen CDC being implemented on these kind of document databases or JSON and NewSQL databases. But having said that, there are tools out there in the market. Like I think MongoDB also has a tool that allows you to capture those events. So essentially, the way you have to think about is you have to break down that problem. JSON always has a structure, always has a schema. So
Right.
let's say the schema is not changing, you can basically similarly capture those events on top of those change, particular attribute within a JSON, right? If there is a schema change, then there are mechanism like Debezium also, I think, has a NoSQL way of capturing, I mean, way to capture schema change also to
Right.
enable CDC on top of it. So that's how I've seen, but I've not widely seen this getting adopted. But these are some of the nuances that I've seen in Debezium. MongoDB also has its own. Some other tools also have it. I think I don't remember a tool name, but there's one more tool that allows you to do that.
Right. Yeah, I think there are a couple of tools out there, but there is not much in this,
No.
like specifically around semi-structured thing. So I'll in the basically kind of a time limitation that we have, I'll quickly present a couple of things that we as a company, DataZip as a company, we are developing in the CDC segment. So I'll quickly just share my screen. Hope you can see the screen.
I can see.
Yeah, so I think we are creating a really great tool for CDC based near real time sort of a data sync into the data lakehouse called OLake. So what we are planning to do with this is that you have majorly CDC's primary use cases to replicate the database data into any data warehouse or a data lakehouse. That's one of the main or biggest use cases. So and the existing tools that you see are having some one or another limitations. So we are kind of creating the fastest tool out there to replicate the data from let's say database. Like we are starting with MongoDB, but we are soon to add like Postgres, MySQL, and this will have multiple features like first load is parallelized, so it's way faster than the existing tools. We are doing a lot of parallelization on the incremental side as well. One of the big changes that we are actually doing is, for example, something like MongoDB. We are pulling the data into the native BSON format and then dumping the data, or basically sort of processing that data from BSON to actually relational format on the ingestion or the OLake side. So the things are more faster for pulling the data. Then our main kind of destination or dump for this is going to be lake houses, because we see the industry strongly moving towards lake houses. All the major enterprises and even early enterprises have started moving towards the iceberg kind of a thing. So that's the primary use case of OLake. You can replicate your databases into data lake houses in near real time kind of a frequency. That's a challenge that we are targeting with this. This is one of the like kind of an early project right now. We have just started this back couple of months, and we have done some lot of good benchmarking for the MongoDB, some test data, and we were actually able to do a really good performance benchmarking in terms of other competitive tools. So for example, Debezium, Airbyte, we were actually basically 6 times to 13 times faster. Fivetran, which is a paid offering in this the whole change data capture or the data sync tools, is we are 4x faster. And this whole thing that you see is an open source thing. It's live there on our website. You can visit datazip.io/Ole to track the progress, to see new features coming up with this. And basically the OLake has really good features in terms of we are dumping data into open formats like Iceberg, so you don't have to have a query or vendor lock-in in any of the proprietary warehouses like Snowflake or Databricks or some Redshift or something. And we are going to actually put a lot of focus on alerting, basically because we understand how difficult it is when your schema changes and your sync starts failing, or because of some random issue your table is not being synced. The CDC cursor has passed, so we are going to put CDC cursor has expired basically. So we're going to put in all of these kind of monitoring into place for the OLake, and then real time basically, which is one of the primary requirements these days. And it's really difficult to get near real time or real time kind of a sync frequency in the lake houses, especially because lake houses are a little slower compared to really fast data warehouses like Lakehouse. So these are the 3 primary sort of features that we are targeting. You can check out the GitHub. You can visit datazip.io/Olake, and then you can get the GitHub link from there, and you can also join our Slack community if you're interested in what we are doing, and give Olake a try in your own staging or productions. So that's quick update from my side. You can visit the page for any further updates. So I think we are almost at the end of the session. There are still a couple of questions left, but I believe that we can take these questions later, because we are already done with the time. I think Varun, it was really nice talking with you. You presented a great deal of concepts around CDC. Thank you so much. Thank you for presenting all of this. Harsha, please take over, and all thanks to Harsha as well. She organized this. You're on mute, Harsha.
Well, Harsha is. I think you have to remove the mute button from Harsha's.
No, I was just giving the stage, but thank you so much, Varun. I was just telling, to the people before you joined in, Shubham, that Varun has been so helpful to us. He has been so helpful while crafting the agenda with me as well. Really had a great time working with you, Varun, on this webinar and crafting the agenda. We have had some great engagement and some great turnout from people as well. I hope people loved it. I loved it personally. So thank you so much, Varun, and thank you so much, Shubham, for coordinating with us and putting your insights as well. Yes, looking forward to